Right. Welcome back, everybody. So we're just about to begin our session with Michael Adrian on ISO20022 and effect support within Mojaloop. But just before we go there, I did want to give everybody a quick heads up on our end of day open discussion. So at the end of every day, we have half an hour for open discussions, and this is an opportunity for you all to suggest topics and create breakout rooms for discussions of various topics. If you go to the Pathable page on the daily open discussions, there is a list of a place where you can put and view topics. So you'll see, if you click to answer or see the results, click here to answer, you'll see we already have 2 suggestions for topics for today's end of day discussion and 1 for tomorrow. Feel free to enter your own if you want to propose a discussion group or a topic of discussion, or feel free to use a thumbs up to either to vote and endorse topics that you'd like to have discussions. And then at the end of the day at 4 p.m. to 4:30 UTC, we'll create some rooms where these discussion topics can happen, thus enabling you to have a more deep dive interactive discussion with each other on each of these various topics. So please spend some time on this page. I'll stop there and I will pass it over to Michael Richards.
Thanks very much, Simeon. And hello again, everybody. Let me share my screen. Okay, seeing that?
Looks great.
Excellent. Okay, so this is to bring you up to date with our progress on the on providing support for ISO20022 messages in Mojaloop. Now, for those of you.
Oh, hey, good morning, Keith.
Good morning.
Hey, nice to meet you.
Good.
Oh, that's interesting. For those of you who don't know, ISO20022 is a messaging standard for financial messages which institutions can exchange between each other to effect not only payments but also lots of other different kinds of financial activities that people, particularly banks, undertake. I mean, I don't think anybody would be accusing me of rocking the boat if I said that it's essentially bank-centered, but it is more or less the standard for the structure of financial messages worldwide at the moment. We have had a lot of interest in the past from people who said, well, Mojaloop sounds great, but do you support ISO20022 messaging? So one of the things that we decided to do probably about a year ago now was to try to integrate a means of supporting these messages into Mojaloop. And this is the work stream that I'm going to be reporting on for you today. The idea eventually is to create a reference messaging implementation for ISO20022 that any adopter can take and adapt for their own local needs, which really means 2 things. First of all, changing Mojaloop so that it fits ISO20022, and changing ISO20022 so that it fits Mojaloop. I think you can probably guess which the easier of those is going to be. But in any case, I'm going to start off by talking about how to change Mojaloop to fit ISO20022. And really, this is a 3-stage process. So first of all, we need to select the ISO20022 documents that we want to correspond to the existing Mojaloop endpoints, given that we're happy with the way Mojaloop works today and think it's a good thing to do, which I think we do. Then we need to be able to map the ISO20022 document content into and out of Mojaloop, where the Mojaloop content might be a message using our existing API definition, or it might be a new format message, which is just a switch format version of the ISO20022 message. So at the moment, in version 1 of our architecture, the switch expects to see and work with messages which are in our standard format. One thing that we want to be able to do, and I think you will have seen that in the reference architecture presentation earlier today, is to be able to absorb messages of different kinds and turn them into a single version for ongoing processing. So effectively, we'll be working on a Mojaloop internal version of a message and not on the message itself as we do today. So let me look at these then in rough context with each other. So first of all, looking at the ISO20022 documents that we want to correspond. As you know, we've got a 3-stage process. In the first stage, we identify the person that we want to pay. Second stage, we set the terms of the transfer. And in the third stage, we actually make the transfer. So, the way things are today, when we issue a request to find somebody, it's an HTTP GET. It doesn't have a message body as such. It just says, tell me who owns this identifier. We process that through and it goes to the person who owns the customer. And then the customer responds with information about the payee. And that distributed format is one of the things that we think is important about the way in which Mojaloop works, important and useful. Next, we set the terms of the transaction. We propose the terms of the transfer. That's sent through to the payee after having gone through a rules check at the switch. And then the terms of the transfer are set by the payee and sent back to the payer. Finally, we request the transfer be actioned. Some processing takes place in the switch and it goes to the payee DFSP. And finally, the payee DFSP returns a result of the transfer. So as you can see, for a standard transfer, and that covers P2P, P2B, lots of different use cases. But the standard transfer has essentially 6 messages, as long as you don't count the HTTP GET at the beginning, which isn't strictly speaking a message itself. So when we map those onto ISO20022 messages, we have a reasonably good fit, I think, with existing ISO messages. So there are 2 cache management messages, 03 and 04, which correspond with the account lookup process. We have a request to initiate a payment and conversely a response that basically says, please action this payment. It's essentially equivalent to a request to pay in the pane 013. Then we make the transfer using a transfer request and we get a response back saying what happened. So we think that we are reasonably confident about being able to map our orchestration process, the way in which we structure the nature of a transfer, onto ISO messages. So let's look now at the second phase of our process. Now we need to map the ISO document content into and out of the Mojaloop content. And what we've been using for this is essentially a relatively manual process, which looks kind of like this. So here's an example of how we map an ISO PAX 008 message onto a Mojaloop existing post quotes message. So down the left-hand side in this column here, you will see the existing Mojaloop message structure. There is some typing that goes on there, and these are the mandatory fields that have to be there in the Mojaloop message. We comment on this, and we can see that in some cases we invent things because there is no direct mapping with the ISO format. In other cases, you'll see over on that ISO field column an XPath identifier of the data item in the ISO message that we are going to map onto the corresponding field in the Mojaloop message. So a developer can pick up this mapping and say, okay, I can see now how to fill in all of the fields that I need to fill in the Mojaloop message based on the stuff that I get from the ISO message. Now, this is just an extract, of course, it doesn't contain all of the fields in the message. I select it in order to give an illustration. The other thing that I want to point to is that one of the things that we do in most of our Mojaloop messages is we have an extension list, which essentially is a set of key value pairs that people can use, implementers can use to pass information that we unaccountably didn't think of when we were designing the interface, but which nevertheless may be of interest and use to them. And we propose to use these fields to pass a lot of the end-to-end identifiers which we get from the ISO message, so that although they are not directly usable because they don't have the correct UUID format that we need, nevertheless, we can pass them through to other parts of the system so that when those messages, for instance, are logged in the switch will have information that can be used in case of any dispute to say, okay, this Mojaloop message represented this message ID that was received in an ISO message. So that's the way in which we do these sorts of things. So it takes probably about a day to define 2 or 3 of these messages. We've used them, originally we used them in our hackathon entry. And we've extended that for the real Mojaloop ISO implementations that we are engaged in at the moment. So finally then, we want to look at what we're converting to. Now, as I say, the alternatives are either a Mojaloop internal format message or a Mojaloop switch format message. And I want to talk about how that process might work. So let's look at the way in which a message goes through. So you can see that from the originating participant, a message is sent to the proxy, to a proxy, which converts the message, sends it to the Mojaloop switch. The Mojaloop switch goes through its internal processes, if it needs to. Not all messages need an internal process. For instance, some of the acknowledgements are just simply passed back. They're not processed internally by the switch. But in any case, there's an outbound message which goes through a proxy on the other side, which converts it, and that message is then sent to the receiving participant. So essentially, there are 2 places where we could inflect. First of all, when we convert from the source format to the target format. Now, the recipient of the message in each of these cases sees what they expect to see, but everything between those arrow points, 1 and 1, occurs in the internal format of the Mojaloop switch. So essentially what we're doing is we are translating back and forth between the 2 versions. The other inflection point says the message flow between the participants is always of the same kind. But in cases where the switch needs to do some internal processing on the message, then it converts that into a standard form, and the processes work on the standard form. So they don't care whether the message originally was an ISO20022 format message or a Mojaloop internal message, or indeed any other form of message. They just have something which converts that message into an internal format message and processes it like that and sends out something which converts it back into the whatever format is being used by the switch. And that essentially is the process that you saw illustrated earlier this afternoon in our reference architecture presentation. So in the first case then, we get an ISO message going to the proxy. That's converted into an internal format message. All of that processing is done on the internal format message, and then the proxy converts it again to an ISO message on the way out. In the second thing, it's ISO all the way through, as you can see, except that the switch converts the message into a canonical format for internal processing. So those are our two alternatives. Mapping to FSP IOP messages, well, it's performed in Payment Manager or some other proxy. It doesn't matter really what it is. In its favor, there are no modifications required to the Mojaloop switch. We can just continue to use the Mojaloop switch as we currently have it. On the other hand, it's restricted in the message content that can be transmitted. And in particular, as you've seen, we've been adding bits of information that we don't have space for or which are not in the right format to key value pairs at the bottom of our message. Now, there's obviously a limit to the amount of that we can do. And certainly given the very large number of data items in an ISO20022 message, we would run out of space quite quickly if we tried to do that in the long term. Second, it doesn't support some forms of end-to-end signature, and in particular, end-to-end signatures which use the ISO20022 business application header. Now that's an optional add-on to any ISO20022 message, which can be used to contain a signature for things like non-repudiation and that kind of thing. Now, obviously, in a situation where we are converting back and forth between formats, non-repudiation signatures will not work correctly if they are part of that format. And finally, it requires the use of a proxy. Now, what we have said in Mojaloop up to this point is that although people may find it very useful to use a proxy, we don't want to insist that they do. But this approach really does require the use of a proxy. So, mapping to Mojaloop switch messages, I mean that the conversion is performed in the switch. It means that full structure ISO20022 messages can be exchanged between participants. It means that all forms of non-repudiation signature are supported because the message that the recipient gets is exactly the same message as the sender sent. There's been no conversion applied to the actual message itself. The argument against that is that it requires changes to the switch code. So, which approach do we intend to take? So we need to perform the mapping in any case. We need to understand what the relationships are between the information that Mojaloop needs and the information that ISO20022 is able to provide. So we start with approach one, which is to use a proxy because it's simple to implement. We don't require any switch changes. And then we move to approach two, which is to convert in the switch. And essentially, the advantage of this approach is that we can reuse the mappings that we developed for the first approach, because effectively all that we then need to do is to say, how are we mapping the ISO data elements onto the information that's required, that's actually required, the canonical form that's required for processing in the switch. Now, we obviously at this point need a new switch component which converts an ISO20022 message to an internal format, canonical format message. And again, that's something which is aligned quite clearly with the reference architecture that you'll have seen outlined earlier in the day. But at the moment, this can be the existing FSP IOP message, the existing internal format message, because what happens at the moment is that a request comes through to the switch and the switch puts that request onto the its internal queue for processing by the switch. Now, we already know, as we know, how to convert an ISO20022 message into an internal format message. So in the first instance, all we need to do is do that inside the switch instead of in the proxy. And the version 1 version will continue to work. But subsequently, of course, it'll be the new reference architecture canonical format. But as part of our development for the second part of these things, we will be building something that does that conversion in any case, and we'll be doing it for the Mojaloop internal messages as well. So it'll just form part of the work that needs to be done in order to develop the reference architecture version of Mojaloop. So where have we got to? Well, here's an example of a mapping. This is an internal format. Sorry, this is an ISO20022 format message that's coming in. You will see at the top line that it's a cache management 003 message, as I talked about. And it has a type of identifier. In this case, it's the account ID, which you see highlighted in red, and a value for the identifier, which is the number that you see highlighted in green. To convert that to a Mojaloop request, which is a simple get parties, all we need to do is to do the conversion from the ACCT ID identifier to the fact that this is an account ID, and then add on the end of that the value for the identifier, and we've got something which is more or less exactly, well, sorry, well, I'll rephrase that, which is exactly what someone would expect to see if they had issued a Mojaloop request for a particular identifier. The response then that we see is Mojaloop sends back a put parties request, as you can see there on the left-hand side. It has the account ID highlighted in purple, and the value that was originally sent in, and we have a first name and a last name. Actually, I could have put just the name, but I didn't. So our conversion process converts that to an ISO20022 message, which you will see near the top is the CAMT004 message. The information to the right of that is just versioning. You can ignore it for these purposes. And we return the account, the identifier that was sent through, and the name that was returned. So this enables us to do name discovery for the ISO20022 messages. So that's the sort of conversion that we're doing. This is actual examples of Postman scripts that we're using to test our implementation. And so far, I am happy to report that, broadly speaking, it's working well. So we have directory lookup, happy path is working, malformed request, which returns a 400 because these are synchronous requests in the ISO20022 world, and identifier not found, which returns a CAMT004 message, but with a return code that says, I looked for this identifier, but I didn't find it. We've also done the payment request, and we've got the happy path working and the malformed request working. So all of these are currently working using a proxy. The only thing that we have to complete on that is a small number of the error returns from the payment request, but we're working on those at the moment. And I am happy to report that these are implemented by proxies at present, but we are in a position very nearly to demonstrate an end-to-end flow of P2P message using ISO20022. We have a real customer for this. We are working on it with them, and we are looking forward to demonstrating a working version of an ISO20022 Mojaloop using these structures in the near future. We do have some outstanding issues. So in particular, there's the Mojaloop fulfillment and condition. Now, without wishing to get too technical, one of the key things that we do in Mojaloop is we provide a cryptographic lock that's generated by the payee DFSP, and which is used by the other participants in the transfer, that is the switch and the payer DFSP, to verify that the transfer was in fact completed by the payee DFSP and that it was the payee DFSP that completed it. So I'll come on to that in a little bit more detail in a moment. So let's start to look at what we might need to do to change ISO20022 to fit Mojaloop. So we're now going to move away to a certain extent from purely technical questions. So the questions that we've solved in the first part are essentially standard adapter type questions. How do you change one format of message into another format of message? We're now moving into questions of a slightly different kind. As far as we're concerned, Mojaloop has a special place in the payments world. It's designed to meet the financial needs of the world's poor by integrating the specialists who serve them with the wider financial world. It also wants to reduce the cost of payments by automating processing without increasing risk. And its mission is to develop and implement standards to meet these needs in a flexible and responsive way. So what does that add up to? Basically, specialist services of the kind I've just described have specialist requirements. They will not need to do the same sorts of things that an instant payment system, let's say in a developed economy in the Western world, would need to do. On the other hand, payment systems implemented in developed economies in the Western world don't need to worry about a lot of things that we and the people who rely on us do need to worry about. So standardizing those requirements provides existing payment standards like ISO20022 with, first of all, a challenge that they need to extend their reach to the underserved multitudes of the world. Now, the number of people who don't have access to proper banking services far outweighs the number of people who do. And therefore, any general standardized financial services system will need to take account of the particular requirements of the people who don't have bank accounts, who find it difficult to get access to financial services. And we think that Mojaloop is well, I won't say uniquely, but certainly well qualified to represent the particular requirements of that group of people. But it also presents existing payment standards with an opportunity in that a standardizing organization which has specialist expertise can accelerate that extension, can make existing payments standards more responsive to global needs and not just to the needs of the developed Western economies. So that's what we think. We think that we need something from organizations like ISO20022 because they need to understand that we need to work in the ways we need to work in. But also, we are bringing presents to them. We are offering them something which they could not otherwise, sorry, I won't say they could not, but they would find it more difficult to accommodate without the kind of experience that a community like ours is able to call on people with long-term experience in providing financial services to people who don't have access to standard banks. So our plan for the near future is, first of all, to join the ISO20022 standards organization. Second, to define the changes to existing ISO20022 standards that we need. Third, to make those changes using existing extensibility functions. Now, rather in the same way as we have the extension list that enables us to add things or enables implementers to add things that we didn't think of, ISO20022 has a standard which has a supplementary data field which can be attached to any message to extend the structure of that message. Now, you need to get permission from ISO to use that extended structure, but that is much easier to get than changing the actual structure of the message. So in order for us to in order for us to be able to make the changes that we need to make, we could use those in the first instance, do those in the first instance using the extensibility functions. But finally, we want to extend the ISO20022 standards to serve the world's poor better. Okay, so on that rather excellent ambition, where have we got to? Well, first of all, I'm happy to report that we have formally applied to join the ISO20022 standards organization. We're planning to enlist the services of a subject matter expert, a man whom Adrian has been able to introduce us to, who has detailed inside knowledge of how ISO works and what we need to do in order to be successful. And he will assist us, we hope, in navigating the organizational and technical structures of ISO20022. Now, we need to be sponsored, it turns out, by a national standards organization. And that national standards organization depends on the jurisdiction of the applicant, which in our case is the USA, because that's where the Mojaloop Foundation is incorporated. And for the USA, that's an outfit called X9. Brief parenthesis, they are the Accredited Standards Committee for the financial services industry. They have lots of good things about them to create and maintain US and international standards, improving payments and securities. Well, you can read that stuff as well as I can. However, they do have internal committees, some of which are not of great interest to us because, for instance, they're about things like trading securities and things that our customers are not really very interested in. Others of them are. So there are things about data standards, for instance, about new payments methods and those kinds of things. And they may provide a useful conduit to us for promoting our sorts of our concerns to the ISO standards board itself. On the other hand, since they are USA based, it's possible that they may not have the same sorts of perspectives as we do. Okay, so that is X9. We will shortly be introducing ourselves to the X9 organization and considering whether we should join X9 as well as ISO20022. So that is where we are. That's started. I think all we promised for this PI is that we would make the application to join ISO20022, which is what we have done. Our man in the know, the subject matter expert, is of the view that this the best hope for this is that it might take place, it might complete in 3 months, but it rather depends. So I will hope to be in a position to report positively to you when we meet in September, but I wouldn't necessarily bet the farm on it. Okay, so I want to talk a little bit about specific issues. I've talked before about the fulfillment and condition, but I'm going to go into a bit more detail on that now. But also I want to talk a little bit about how many phases a transfer should have, which may seem an odd question, but I imagine there will be people in the audience whose ears are pricking up at this very moment. So let's look at the fulfillment and condition. It's fundamental to the Mojaloop philosophy because it provides a cryptographically guaranteed link between quotation, the agreement phase, and transfer, the transfer phase. It allows the creditor participant to set the final terms of the transfer, which is quite uncommon in the payments world. There are a couple of reasons why we do that. In particular, because this is a real-time payment system, so we are asking the payee's organization to give the payee money without any immediate guarantee that those funds will be reimbursed. They have to trust us. So we want to make sure that their confidence is increased by allowing them to be in control of the transfer. And finally, it improves the performance overall of the system because all of the non-essential processing can be shifted to the agreement, the quotation phase. And as long as we can make sure, which the cryptographic link allows us to do, that we can always guarantee that the terms of the transfer as defined in the agreement phase are the terms which are being executed. That all works fine. So again, it gives us a significant performance improvement. So it's fundamental then to the Mojaloop philosophy, but it's not directly representable in the existing ISO20022 document formats. And the problem is in particular that ISO doesn't have a format which is capable of representing our signature. All of its text fields, so what we actually pass is an encoded version of the signature itself, and that is of a size too great for any of the ISO identifier fields. So the ISO solutions might be, as I've said, to make a temporary change to the structure of messages using the supplementary data structure, or to make a permanent change to the structure of messages by adding new identifier fields to the message. Our preference is to adopt the second of those. And indeed, the submission that we made as part of the hackathon suggested that we would make those changes. So we have the changes defined already and ready to go. So finally, I want to say, how many phases should a transfer have? Now, Mojaloop's answer, as you know, is 2. It should have an agreement phase and a phase in which the transfer itself is executed. But ISO's answer, broadly speaking, is 1. Why do we like 2 phases? Well, as you know, it allows non-essential processing to be completed before any funds are reserved or committed. It allows the creditor DFSP to control the terms of the transfer, and it allows the terms of the transfer, importantly, to be varied by participants. Now, one of the things that we allow is for the payee DFSP to impose fees on the transfer and to quote those back to the payer DFSP, so that in accordance with our level 1 principles, the payer DFSP can go back to its customer and say, if you do this transfer, this is the total amount that will be removed from your account, and this is the total amount the recipient will receive. So that is a fundamentally important point for us. And as long as the payee can vary the terms of the transfer, we would definitely need the transfer to be done in 2 phases. And finally, it protects the terms of the transfer by allowing either participant to withdraw before the transfer is executed. And it improves performance by minimizing the sequential activities that are associated with the reservation of funds, as Miguel was explaining earlier today. We try and keep that process as lightweight as possible. So this supports RTP, real-time retail processing requirements, in that we need to offer high-speed, low-cost automated transfers using straight-through processing techniques. One of the most expensive things that you can possibly do in a payment system is to have a dispute. So we want to do everything we possibly can to avoid the chance that any disputes will be raised. They need to offer, again, transfers where all the participants are aware of the terms of the transfer, so there can't be anybody causing problems later on by saying, oh, I didn't realize that I was going to be debited this amount. I thought it was only going to be that amount. And we also need to support transfers where the participants don't need to have out-of-band knowledge of each other's charging practices. Now, it's frequently the case at the moment where institutions are of the same kind as each other, or banks, for instance, or all mobile money operators. They have a pretty clear idea of how their business model operates, and therefore they can have out-of-band arrangements that basically say, well, you don't charge me for this and I won't charge you for that. Those kinds of things. One of the things that we want in the Mojaloop system to be able to do is to make sure that there are no special deals between people, that everybody who participates in a Mojaloop system, whether they're a large bank, a tiny credit union, a microfinance institution, or a mobile money operator, they can all participate in the same way, and none of the participants will need to make special allowances for the fact that they're dealing with one kind of participant rather than another. And finally, we want something, sorry, not finally, but we want to have maximum security for all the participant institutions, so that each of them should be as sure as they possibly can be that when they get a message that something has happened in the system, they can trust that message. And we want to reduce transfer-related disputes to 0 or thereabouts. So these are all things that we need to put into the question about whether we should be looking at two-phase transfers or not when we come to talk to ISO20022 about what a genuine global real-time retail payments system standard should look like. Let me then talk about a plan for the next PI, which is detailed documentation on the background and utility of the two-phase transfer, and engagement with standards institutions to promote its availability as part of the standard message suite. So one of the things that we would like to do is to have example orchestrations as part of the ISO20022 documentation suite that explain to people how you would implement this kind of two-phase transfer using ISO20022. Okay, now, was there anything else? Oh yes, foreign exchange. Sorry, this is, it's in the same work stream as this for reasons that rather escape me, but it is in the same work stream as this. So I'm just going to spend the last 5 or 6 minutes talking about where we are on that. So we've written a detailed proposal for how to manage foreign exchange currency conversion as part of a Mojaloop system. It's been reviewed and approved by interested parties, and it's also been reviewed and outline approved by the, well, let me tell you, I was a bit embarrassed at the presentations earlier on because I thought we just haven't got enough acronyms. But I'm happy to say that I have now, with one bound, got my acronym cred right back up to scratch. So the API Special Interest Group for the Mojaloop internal signature has reviewed it and has approved it. So we're happy with that. I think broadly speaking, we are on the right page. There are some small changes that we need to make, but I think that at the moment, at least, we're happy that we have a working plan going forward. For the next PI, we will have a detailed proposal for changes to the API, and we have both breaking and non-breaking versions of that. So depending on how the planning is for next releases of the standard Mojaloop API, we can accommodate either and still move forward with our currency conversion plan. We will have a detailed switch code proposal. The amount of changes to the switch for this are relatively small and restricted, but we don't have them defined in detail yet, so we will do that and arrive at a position where we at least understand the work that needs to be done, even if we haven't done it. We will have a detailed implementation plan for the foreign exchange provider reference implementation. The foreign exchange provider in our terminology is the person who actually provides currency conversion services in a Mojaloop scheme. And what we would like to be able to do is to at least have a simulator version of that so that we can demonstrate a sandbox version of a foreign exchange provision in a Mojaloop scheme. And finally, we would like the API proposal to be approved and, if possible, implemented. So that's where we are on that. And that just leaves me time for 5 minutes of discussion, if anyone would like to raise any points.
Michael, I answered the one question regarding Swift's translator tool, but I think probably you're the best person to answer the question from Miller around whether the Rwanda implementation has influenced the mapping, or whether there's, the ISO20022 interpretation by local implementers is influencing the design we're putting together.
It's not implementing the design, is my view, but then I would say that, wouldn't I? So I think that there are 2 points here. First of all, I think as far as the selection of messages goes, we are happy with the idea. The Rwandan implementation works in a different way as regards the Oracle from the way in which standard Mojaloop works, in that it uses a centralized directory of participants, at present I should say, uses a centralized directory of participants. Our plan is that we will, effectively the Oracle will work rather in the same way that Pathfinder Oracle currently works for Musdans, in that it will resolve requests against the central Oracle as they are currently maintaining it, and the difference will be that the information about the participant will be returned by the Oracle and not, as at present, by the payee DFSP. The reason being that none of the existing participants in Rwanda are set up to receive directory requests and respond to them. They expect to perform this by using the equivalent of our participants endpoint to update a central Oracle with information not only about particular identifiers, but also about things like, for instance, the name of those people. Now, I would say that that is not an ideal situation, and that the way in which we have done it offers considerable advantages, but that's not to say that it's, I think, unworkable in that way. So there are those kinds of changes. It's also the case that they implement a single phase transfer rather than a two-phase transfer. And this goes back to the conversation that we had earlier on. Now, again, they don't allow variation of the terms of the transfer by the payee DFSP. So in that sense, at least, nothing is lost in terms of security by implementing a single phase transfer using the transfer message and response rather than the quotation phase followed by a transfer phase. Again, I don't think that that is in the long term the best solution, but I would say that it hasn't inflected our particular response and particularly our mapping of fields onto each other. Now, one of the things that I want to add to that is that in Rwanda, they have explicitly said that they are happy and indeed encouraging for their participants to use all areas of the relevant ISO2W22 messages to transfer information back and forth between each other. So what they're saying is effectively that even though the processing in the switch may not require it, they are very happy for people to be using the other fields in the ISO message to share information with each other. Now, this obviously makes it problematic for us in the medium term, let alone the long term, not to be able to pass native format ISO2W22 messages through our system, i.e. to move to the situation I talked about in relation to the second inflection point, where we are passing ISO2W22 messages through the system and converting them into internal format messages for the purposes of processing by the switch. So we will definitely have to move to that point. But if you were to ask me, have we made have we made significant changes to the way in which we do these things in order to accommodate the particular requirements of the existing Rwandan implementation? Then I think, and I hope that I've given enough evidence that we have tried at all times to walk the line.
Well, that's great. I guess if I could ask for one point of color. So you may have a particular institution that's leaning forward and prepared to adopt some of the more progressive practices without abandoning ISO as the messaging format. That may then progress as we have a defined ISO RTRP standard flowing out of the committees, of which we would be one member, and our system would be one of the implementers of that much more generic message set. Again, we may find that there are other real-time platforms, possibly for cross-border, that an institution might want to join and therefore implement those ISO messages, the RTRP messages, not the narrow case that we have to start with here. So you could then have a case where you have one participant who's prepared to do more and other participants who are essentially forced to do less. Is there a strategy that you foresee where you could open this up a bit and say that, as you've said, you've captured a lot of this now in the Oracle itself, as opposed to pass through to the systems, as one example? If the individual system said, actually, I'm now going to take a look at those lookup requests and give you the answers myself, we would love that that was true. Can it be done in a way that the payer isn't actually aware of that? That is, the payer simply sees the Oracle interface, doesn't know where the answer is coming from, but it's still considered authoritative, as one example. And so you then have a new ISO message used by this new participant, this progressive participant, that supports this much more progressive use of the ISO messaging formats between that participant and the Oracle, but they have to map somehow into the response that you get back as the payer. That's one example where you've got maybe this mix that you have to resolve as you go forward.
Yes.
So does that make sense? That there's it may be now that everybody simply agreed because they were told to agree by the Rwandan or by our switch, but that over time that may be an unsatisfying condition. And do we have a response within the interface code for that?
I think we do have a response within the interface code, yes. And as you'll doubtless recall, one of the things that one of the strategic decisions that we took when the PISP work first started is that we would support multiple API definitions. Now, it's certainly possible to envisage, I think, a situation where you could have participants in a system using different sets of ISO messages, as long as obviously they weren't using it in relation to each other. And you could implement it in that way, because as long as you have conversion adapters that enable the internal processes of the switch to get information in the form that they want it, the question of how that information actually arrives into the system, into the switch, becomes much less relevant. And it's possible, for instance, to imagine something where you say, well, I would like to be an internal member of the Mojaloop switch using the standard ISO2W22 messages, but I would also like to belong, let's say, to a meta switch, which uses enriched ISO messages or more forward-facing ISO messages. And there would be no reason why we couldn't implement what's effectively a parallel version, so that people who wanted to use the meta version as well as the internal version could do that.
That's great, thank you. It looks like we have multiple ways then that we could move forward to that. As always, I thank you for your depth of study.
Always a pleasure, never a chore. Right, so I think we have trespassed slightly on everybody's goodwill. So I will return the floor to Simeon.
Thank you so much, Michael, and thanks for the brief discussion we had there. We will end the session now. At the top of the hour, we will have Paul Makin and Sam Kumari lead us on bulk payment enhancements. So join us there. Thanks, everyone.